Okay, what we're going to look at now with solids, liquids and gases is spread, or in science it's a word called diffusion. Excuse me. And that is how the things that solids, liquids and gases are made of, little tiny particles, whether they spread amongst each other or they don't. For instance, with solids, I've got two books here, one book and another book. No matter how I try and push them this way and that, or if I got a big pressure on them or put one inside the other, they will not spread amongst each other. So this book will not become a part of this book. However, with liquids, we've got a red liquid here, and we've got water, colourless liquid. If I pour, and you've all done this, boys and girls, but if I pour the red liquid into the, let me move my fingers, if I pour the red liquid into the colourless liquid, they spread amongst each other. There isn't a big blob of dark red liquid at the bottom or the top or in the middle with colourless liquid on top or below that. It's just one liquid, which is a slightly paler version of the liquid in this bottle. And that is diffusion. The particles, the tiny particles of the red liquid spread in and amongst the tiny particles of the water. One way you've seen it with gases equally, they spread or diffuse. Solids do not, but with gases, you can do at home, and I'm sure you've already experienced it. If your mum or dad or carer is getting ready to go out one night and is upstairs and sprays on some perfume or some aftershave, if you walk up the stairs, about halfway up the stairs, you'll smell that aftershave or perfume, or it might be deodorant, whatever. And that is diffusion of gases. So it's sprayed in the bedroom or in the bathroom, and it diffuses away from where it's sprayed down throughout the house, getting less and less strong, a strong smell the further away, but still it spreads. And that is diffusion. So you've got the particles of perfume and the particles of air, and they spray the perfume into the air, and it spreads and spreads and spreads and spreads throughout the air in the entire house. That is spread or diffusion. The second thing I want to talk to you about is expansion and contraction. Again, they are scientific words, but what they mean, expansion is simply getting bigger. Contraction is simply getting smaller. Now, you might find this hard to believe, boys and girls, but everything on this earth, whether they're a solid or a liquid or a gas, if they are heated up, they get bigger. If they are cooled down, they get smaller. Now, I'm going to blow your mind here, but I'm looking at you at home, and you now, in this weather that we're having at the moment, very hot weather, you are bigger than you were in the winter. Now, you would be anyway, because you're growing, aren't you? You're getting older and you're growing. But if you are the same size in the winter, so an adult, same size in the winter, and we're not growing, in the winter or the summer, You will be slightly bigger in the summer, I beg your pardon, in the summer, because it's hotter. As we heat up, we expand. Only a tiny bit. You don't see me twice as big in the summer as the winter, but a tiny, tiny, tiny amount bigger, because everything, simply everything, expands in heat, with heat. And I'm going to show you a couple of examples of that. It's very difficult to show a solid expansion. So what I'm going to do is to show you a liquid and a gas, how they get bigger when we heat them up. So what I've got here, I've put some food dye in some water in a bottle, and what I've done is I've glued, I've had to do this at the lab at school. We have stuff that we can show this quite easily, but I'm going to super glue that top onto the bottle, and I've had to glue this little straw, which is actually a pen top because I don't have plastic straws in the house, but I've glued that shut so it's airtight. So I'm going to glue that in. So what we've got is a straw that runs through the top into the, let me get rid of that, into the blue liquid underneath. Don't know if you can see that. Can you see that running, the straw running straight down into the blue liquid? Okay, which is just water with some food dye in. So what I'm going to do is, when that's set, I'm going to glue it now and then set so that it's set. And then I'll come back and I'll show you a demonstration of liquids expanding upon heat, and I'll do one for gases as well. Welcome back, boys and girls. Right, we have our blue liquid, blue water, with the straw in. I'm going to put this in this pan that's now, the water's bubbling, it's just about boiling, and it will heat up. I'm going to put this into the pan. It should heat up the water inside of here. With this being airtight around here, it should be the case that if this water gets bigger, expands, the only way for it to go is up through the straw. So let's give it a try. With a bit of luck, we may see, hopefully, that blue liquid coming up through the straw. It might take a bit of heating on. Rather than you sit there for forevermore waiting for some water to heat, I'll just switch off and I'll bring it back when I know it's just about to start coming up the straws. You see it right at the top there, here it comes. Can you see? It's now coming out of the top of the straw. Falling into the saucepan. And the reason that is happening, boys and girls, is because, as I explained to you, there is nowhere else for that, I'll turn that off, for that expanded water to go. That water getting larger in size, because this is all sealed, it can't go anywhere but out through the straw. Okay, one final thing I'm going to show you. I'll have to be careful of that. Let me get my tongs. One final thing I would like to show you is gases. Now this is still very hot water, and what I've done with this bottle is I've put a balloon on it. Just put it's not balloon blown up, obviously. Put a balloon on it, and again, all the air in here, there's no water in this bottle, all the air in this bottle, if it expands, has to go find room at the top here in the balloon. So let's see what happens when I put this in hot water. See? It's blowing up the balloon. I haven't done anything strange about this. It's just simply that the air in this bottle, as it gets hot, has to go somewhere, so it tries to go out through the balloon and blows the balloon up. If I then put that in some cold water, it then starts to, you can't see that so well, can you? It starts to deflate, and eventually, probably better with a bigger pan of water, but you can see it's now droop, bloop, and the air has gone back out. Put it in the hot water, blows up, so the air is getting bigger, or as we call it, expands. Contracts or gets smaller when it's in the cold liquid. So the the air in the bottle is getting colder until it eventually goes back inside the bottle. Okay. Well, boys and girls, that's the second of the home science. Let me just put that there. Second of the home science tutorials I've been doing. I will catch up with you next week with a third one. Hope you enjoyed it. Bye bye.